Okay. So this presentation is on behalf of Women Tech Makers Seattle, and I'm so happy to be here. And what we are going to do is we are going to go through the DMIC methodology for Six Sigma projects. And I'm Eloisa, Elias, and I work for the manufacturing industry for almost 9 years, and I developed many Six Sigma projects, and we did savings to the hundreds of thousands of dollars. And just as a context, right now more than half of the total 500 Fortune companies, they are implementing Six Sigma methodology in their processes. And everybody hears about Lean Six Sigma and different kinds of names. All of them are the same, like a Six Sigma project. And the reason I wanted to provide this perspective is because is how to introduce the Six Sigma methodology with data science. How you are an expert as a data scientist can combine the methodology with all your statistical knowledge and your machine learning knowledge, and make Six Sigma projects for your companies. And right now we are going to make a recording pause because I'm going to show you a very brief video regarding how I see it as a Six Sigma project. And
grosse caisse bien, grosse caisse bien, grosse caisse bien. Tu vois, il y a un truc un peu... Recording, bah vas-y direct. Recording.
so this was a very fun video that I found, where you have the process owner and doing the whole work, following the recommendation from the Six Sigma expert, and at the end, a Six Sigma project, the Six Sigma expert give advice to the process owner so they can implement controls to all the improvements that you do through the Six Sigma methodology. And now we continue the recording. And so what is Six Sigma? Is the degree of variation in a process. And in Six Sigma, we focus and measure the defects and the variation of our processes, so we can create projects for continuous improvement. And the goal is to minimize variation and to center the process. And the Six Sigma requires the DMIC methodology, which means define, measure, analyze, improve, and control. And the main reason that we create the Six Sigma methodology is to measure and quantify our process capability. The process capability, usually we call it CPK, and it is how centered is your process and how within the specification, the manufacturing specification, your process is. And we study, we do a Six Sigma project by using data and as stratified sampling in order to predict the goal of the project, or what we defined at the beginning of the project. And just for everybody to have a perspective, in here on the left side we have the Sigma for any kind of project, we are able to quantify the sigma. So when we talk about 6 sigma, we talk about that we are going to have 3.4 defects per parts per millions. So that is huge in manufacturing. We always try to achieve, which is not easy, in my experience, 6 sigma. The process, once you measure the process, sorry, once you measure, you are in the measured stage of the DMIC methodology, the process with time is going to move 1.5 standard deviation. This is a well-known data point for us in 6 sigma. And as a reference, it would be a 99% good of manufacturing goods would be that we have a 3 sigma process, and it would be in the thousands of defects per millions products produced. So if we have a 6 sigma process with the same in the same area, we go from thousands of defects to only two digits, in this case maximum, of defects. So how do we combine 6 sigma and data science? So for this presentation, I'm going to take you from the comparison from the DMIC methodology to the methodology that we use in data science, which is the CRISP DM. And just as for your information, the DMIC methodology was created by Chrysler, Ford, and General Motors, and the American Association for Quality. I think that is the name. I forgot the precise name. And the CRISP DM was also created in part with Daimler Chrysler. So they overlap a lot. From my perspective, I believe they overlap a lot. Just I'm going to tell you about an example that would be if a company wants to predict customer churn, which is a task that we, as a data scientist, we are asked very commonly. We, as a data scientist, we go immediately to check out the possible algorithm that we can use to feed the data. And a 6 sigma expert, what we'll do is to analyze the data and measure them and make sure that the data is under control and within a specification. So for this presentation, I created a 6 sigma roadmap for you, and I'm going to have some copies if you want to grab one copy. So you can create your 6 sigma projects and your workplace. And I'm also posting this document into my GitHub. So we are going to go from define, measure, analyze, roadmap to improve control, and we are going to go step section by section and comparing a 6 sigma in manufacturing, how it's implemented with data science points. So in the defined stage, what we do is we really try to identify what is important for the customer. For us, our priority is our customer, internal or external. And for this, we use, in 6 sigma, we start with Pareto chart and input-output diagrams and trees, and use classic statistics measures to to just visualize the current perspective of the process. So we can start asking questions about what is important for the customer, what is the objective of the project, and everything has to align at the end with the major business strategy. And for this, what we have is, as an output, is a statement of work where we defined the goal of the Six Sigma project, and we create just a draft of the project plan, which of some graph and metrics. And the comparison for the defined stage would be for data scientists. For a Six Sigma project, you use 35 samples that were taken stratified in a stratified way. And for data science, we use millions of data points. So it's a huge difference to go from 35 data points to millions. So in data science, we also in machine learning, we use a lot of data mining, visualization, but all of these points are covering the same point, the same theme that we want in defined. We want to have a perspective of what is going to be the project objective and what is going to be a clear goal for the whole team. Sorry. Then we go from define, we go to measure. It's the second stage of the Six Sigma project. And for this stage, what we do is now to get metrics of the current status of the whole process. So just to realize, we are not doing in measurement, we are not trying to do predictions, we are not trying to figure out where's the data going. We just want to have a photo of what is currently happening in the process. And so for this, the output would be that we now with the data, we redefine the project statement, and we have to validate the measurement system. That is something. Oh, okay. I don't know. Can you see it? Which one? Oh, okay. Oh, thank you. Oh. Okay. And in here we have to something different that I noticed from my field in manufacturing to now to data science is that in manufacturing you have to validate your data. You have to be sure that the features, the parameters that you are going to utilize in order to do prediction in your Six Sigma project, they need to be centered, they need to have good capability. That means that what we are measuring, it has to be within the specification, and hopefully you have that feature that you are measuring, hopefully it would be above 3 sigmas. And our recommendation from the manufacturing industry is this book. This is a great guide for you to validate your your measure stage. And from the data science perspective, we check our data with cross validation, with MAE and F1 scores, something that you can utilize. And for the analyze stage, now in here we have all our features under control. We validate that those features are good data, that we can utilize all the data that we have. And now we start validating from the problems that we define at the beginning of the project. We start selecting from those features what are the features who really impact our end goal. So for the analyze, we usually, from all the variables that we selected, we utilize like a design of experiment in order to validate those variables that they are affecting my Y, which is the objective of the project. And now it would be from the data science perspective, it would be when we start doing now the regression models or any kind of machine learning model, and start seeing predictions and start testing which of our variables are affecting our end goal. And now for in the improve stage, now we, from those data features that we already validated, we just take decisions as a group with the process owner and the Six Sigma team, and then you implement those improvements into the process. For this, usually what we have in manufacturing, you validate your improvement with 3 months of data, which is a long time for us from the data science perspective. And the analogy for data science would be that when we do improvement, we refine our parameters, we create new data, we implement actions according to our predictions. And at the end, we have the control, which is how we maintain everything that we have implemented and into our processes. And for this, we provide a statistical graph and measurements of the CPK of the process, and we implement controls into the process, but we need to figure out if the controls are being in place. So we extend this another, usually 1 month, and we revisit it again a year after for manufacturing. And we check out if we can transfer the knowledge to another area. And for data science, it's something more fast that we could affect or implement new KPIs or implement it in our dashboards. So the takeaways from this presentation would be that Six Sigma is a methodology to improve a business process, and we need to have everything that we are measuring, and we know that all the variables that we are using in order to make predictions, they need to be under control, and they have to have good CPK, which is everything has to be within the specifications. And we mainly are focusing in our customers. So right now, machine learning and AI, we try to be more efficient and faster. But I believe, from my perspective, and it has worked in some projects, that following this Six Sigma methodology provides you, from my perspective, a faster way to check out if you are going to have a good prediction or a good goal at the end. So it would be an improvement of the way you currently are using your data science models. Just it would be like another kind of process. And with that, I'm finished, and I'm going to post this document that I created. And please, any questions?